We have ourselves two exam questions here. In the first one, we'll be finding the dimensions of velocity, force, and density. In the second one, we'll be using dimensional analysis to find and derive the equation. With that in mind, let's get into it. So let's answer our first question here, which is write down the dimensions of velocity, force, and density. Let's begin with velocity. Number one, velocity is equal to displacement over time taken. Now, the dimensions of velocity, displacement is a length and time is t. Therefore, the dimensions of velocity are L, t, -1. Next up, the dimensions of force. Force is equal to mass times acceleration. The dimensions of force, mass is capital M. Now, acceleration, do we know the dimensions of acceleration? We can find them. Acceleration is equal to velocity over time. Now, the dimensions of acceleration, velocity, we know the dimensions of velocity, we found them. LT -1, so that's LT -1 over the dimensions of time, that's t. This can also be written as LT -2. So this is m multiplied by LT -2. So these are the dimensions of force. Now, last part, we'll be getting the dimensions of density. Density, given by this symbol called rho, is mass over volume. Mass is a capital M. These are the dimensions of density. Now, volume. What's the dimension of volume? Volume is equal to length times breadth times height. Now, length and breadth and height are all length, so they're all represented by L. So that's L by L by L. These are the dimensions of volume. This becomes L to the power 3. So therefore, the dimensions of volume are L to the power 3. You can write this as ml -3. So we've answered our first part, the dimensions of velocity, the dimensions of force, and the dimensions of density. You can write them by the side. So we can write them by the side here. The dimensions of velocity, that's LT -1. The dimensions of force, that's MLT -2. And the dimensions of this density, that's ml -3. Okay. Now we can move on to the second part. A Toyota Harrier moving with a velocity v experiences a force F due to air resistance given by this expression right here, where C is a dimensionless constant. This is a very important statement. C is a dimensionless constant. Code the drag coefficient. Rho is the density of the air and A is the cross-section area of the vehicle. Use dimensional analysis to find the values of the powers of x, y, and z. So let me write our equation. F equals 1 over 5 c, our dimensionless constant. Then we have rho to the power x, v to the power y, and a to the power z. Now, the principle that we're using to get this equation and the powers of x, y, and z is the law of homogeneity. It states that for an equation to be valid, the left-hand side must have the exact same dimensions as the right hand side. So that's the law that we're going to use to get the values of x, y, and z. So let's go ahead and put the dimensions of force on the left hand side. Dimensions of force which we got are m, l, t, -2 is equal to, now in this case, 1 over 5 and c are constants, and constants don't affect the value of x, y, and z. So we can ignore the constants. That's why this statement was important, that c is a dimensionless constant. So we can ignore 1 over 5 and c. Now, rho to the power x, this one is ml -3. So we can put it in parentheses, ml -3. This is to the power x, multiplied by our v was velocity, that's lt to the power -1 to the power y. Lastly, we have area. What's the dimension of area? We didn't find, but we can find it. Area is equal to length times breadth. Now the dimensions of area, length and breadth are both length. So that's L multiplied by L, which is L squared. So the dimensions of A is L squared. So we can put L squared and then to the power Z. Let's simplify the right hand side. We have m. If we open parentheses with the exponent, this is m to the power x multiplied by l to the power -3x multiplied by l to the power y multiplied by t to the power -y multiplied by l to the power 2z is equal to ml t -2. Now, the law of homogeneity states that the left-hand side dimensions have to be equal to the right-hand side dimensions. That means that m has to be equal to m, l has to be equal to all the l's, t has to be equal to t. So we have to identify how many m's do we have on the right-hand side and equate them to the one on the left-hand side. So in this case, if we look around, we only have one m. So m on the left-hand side is to the power 1 is equal to m to the power x. For the left-hand side to be equal to the right-hand side, we have to equate both m's. Now, to get the value of x, if the bases are the same, it means the powers have to be the same. Therefore, x is equal to 1. We've gotten our first variable. The next one we want to look for is L. How many L's do we have on the right hand side? We have this one, and this one. So L on the left side is L to the power 1 is equal to L to the power -3x multiplied by L to the power y multiplied by L to the power 2z. Now, according to the law of exponents, we have to simplify the right hand side, and if the bases are the same, when multiplying things that have the exact same base, the powers are added together. So this is L to the power -3x plus y plus 2z. Applying the law of homogeneity, it means that 1, which is the power on the left side, is equal to -3x plus y plus 2z. Now, we have the value of x, but we don't have the value of y or z. So let's keep this one as it is and go to t. We go to t. So we have t to the power -2 is equal to, how many t's do we have on the right side? We only have one, which is t to the power -y. If the bases are the same, the powers have to be the same. Therefore, this is -2 is equal to -y. Therefore, y is equal to 2. We found our second variable. Now with this, we can find the value of z, because we found x, which is 1, and we've also found y, which is 2, plus 2z. This gives us 1 is equal to -3 plus 2 plus 2z Simplifying this side, we have negative 1 plus 2z is equal to 1. If this 1 goes this side, we have 1 plus 1 is equal to 2z. So 1 plus 1 this side is 2 is equal to 2z. Therefore, the value of z is equal to 1. And there we have it. We have our values of x, y, and z. X is equal to 1, y is equal to 2, and z is equal to 1. Let me write them on top here. X is equal to 1, y is equal to 2, and z is equal to 1 as well. Now, the last thing we should do after we found these is replace these exponents into the equation. So our equation was 1 over 5c. This is f equals 1 over 5c. We found x is equal to 1, so this will be p to the power 1. And velocity, our y is equal to 2, so this is to the power 2. And a to the power z, our z is equal to 1. Therefore, this expression is 1 over 5 z rho v squared a. And this is force. And there we have it.